Today we are going to solve a pulley problem. There are two boxes with mass 0.8 kilograms and mass 0.3 kilograms connected by a massless frictionless string over a massless frictionless pulley. Now what we have to do today is write some free body diagrams for each of the boxes. So that'll be M1 and M2. We have to find the magnitude and direction of acceleration, and we have to find the tension force, which I will show you later. Now for the free body diagrams, what we have to know is that both masses are connected by a single string. Therefore, the tension force will be the same for both, like so. However, the gravity force is going to be different for the two boxes. The 0.8 mass is going to have a bigger gravity force than the 0.2 box, or 0.3, mass 2. All right, there are our free body diagrams. Now for something more difficult, we're going to find the magnitude and direction of acceleration. Now, we are expressing the down direction for the 0.8 kilogram box as the positive direction, because the movement of these two objects is going in this direction, and we want to know, we can choose, but the most obvious choice would be to choose whichever direction the two objects are going into to be the positive direction. Therefore, for our two equations, we're going to have it be M1G minus tension force equals M1A. Now this is obviously the gravitational force, and the only hinderer that it has is the tension force, and force equals mass times acceleration. Now, for the other object, we're going to have tension force minus M2G equals M2A. Now, something important to know is that these two objects are moving at the same acceleration. They're in a system. So this acceleration equals this acceleration, which will make it a lot easier to figure it out. Now to figure out the acceleration, we're going to add these two equations together, which is going to give us M1G minus M2G equals M1A plus M2A. Now we're going to factor out the G and the A on these sides, so it will be G times M1 minus M2 equals A times M1 plus M2. And we're going to divide by M1 plus A2 on both sides. So it's going to give us acceleration equals G times M1 plus M2 divided by M1 plus M2. Let me fix that, a little mistake there. And we plug in our values. That's going to give us G 9.8 times 0.8 minus 0.3, yes, divided by 0.8 plus 0.3. And this will give us approximately 4.45 meters per second squared, which is our acceleration. Now let me erase some of this that we don't need so we can find tension force, which is a lot easier for us to find now that we have the acceleration. For tension force, all we need to do is plug in the values to one of these equations. Now I'm going to use the easier one right here. So it's going to be Ft equals M2A plus M2G. And I'm going to factor out M2. So it will be M2 equals A plus G. Now when we plug our values in, that'll be 0.3 times 9.8 plus 4.45, which will give us approximately 4.28 newtons of tension force. Thank you.